to our lesson on Chapter 4, Part 2. This lesson will begin by discussing the cases, the types of computer cases. Well, there are several types of and sizes of cases that are on the market for each form factor. The computer case, sometimes called a chassis, houses the power supply, motherboard, expansion cards, and drives. The case has lights and switches on the front panel that can be used to control the monitor or control and monitor the PC. But generally, the larger the case, the larger the power supply and the more amps or current that it carries. These large cases allow for the extra space and power needed for a larger number of devices, such as multiple hard drives needed in a server. Computer cases come in different colors and have cool features such as a clear plastic panel so you can see the lights inside. Ports that connect by cables to the motherboard might be mounted on the front, top, side, or rear of the case. And when you select a case, be aware that the power supply is often included with the case, and it's important to match the power supply to the electrical needs of the system. How to do that is coming up later in this chapter. Now, cases for personal computers and notebooks fall into three major categories: desktop cases, tower cases, and notebook cases. Now, the picture behind me shows an example of each of the three main tower cases, as well as two desktop cases. In the following topics, we'll discuss them each in turn. First, the desktop cases. First-person computers use a desktop case that sat flat on a desktop, doing double duty as a monitor stand. The motherboard sat on the bottom of the desktop case, and the power supply was near the back. And then if you have a desktop case designed to lie flat, don't place it on its end because the CD or DVD drive might not work properly. Desktop cases are built to accommodate all form factors for personal computers. Now, because of the space a desktop case takes, it has fallen out of favor in recent years and is being replaced by smaller and more space-efficient cases. For low-end desktop systems, compact cases, sometimes called low-profile cases or slimline cases, follow the Micro ATX, Flex, or NLX form factor. Likely to have fewer drive bays, they generally still provide for some expansion. Some cases lay flat and can be used as a monitor stand, and others stand upright, and you can see an upright slimline case here behind me. Slimline desktop cases are gaining in popularity for low-end personal computers because they come in nice colors and do double duty as a monitor stand. The tower cases sit upright on the floor or a desk and can be as high as 2 feet and has room for several drives. Often used for servers, this type of case is also good for PC users who anticipate upgrading in the future, because tower cases provide maximum space for working inside a computer and moving components around. The variations in tower cases are as follows. A mid-sized tower, also called a mini tower or mid-tower, are the most versatile and most popular. They are mid-range in size and generally have around 6 expansion slots and 4 drive bays, providing moderate potential for expansion. They're used for ATX, Micro ATX, Extended, Mini, and BTX systems. The mini tower, also called a micro tower, is the smallest type of tower case and does not provide room for expansion. They are popular for Micro and Flex ATX systems. The full-size towers are used for high-end personal computers and servers, usually built to accommodate ATX, Mini, and BTX systems, as you can see behind me. Now, the notebook cases are used for portable computers that have all the components of a desktop computer. The cost and power of notebook systems vary widely, and as with other small systems, notebooks can present difficulties in expansion. The smallest notebook cases are called sub-notebooks or netbooks. A notebook design is highly proprietary, but are generally designed to conserve space. They allow portability, use less power, and produce less heat. The case fan in a notebook usually attaches to a thermometer and runs only when temperature needs to be lowered. Now, toward our goal for learning about power supplies and electrical current they provide, let's turn our attention to understanding how electricity is measured and about some of its properties. In our modern world, we take electricity for granted and we miss it terribly when it's cut off. Nearly everyone depends upon it, but few really understand it. But to become a successful PC technician, that is, you don't tend to encounter fried motherboards, smoking monitors, or frizzed hair, then you need to understand electricity. Now, in addition, you need to know how to use it, how it's measured, and how to protect computer equipment from its damaging power. So let's start with the basics. To most people, volts, ohms, watts, and amps are vague terms that simply mean electricity. Now, all these terms can be used to measure some characteristic of electricity, as shown here behind me. Now let's take a look at how electricity gets from one place to another and how it's used in house circuits, AC and DC. Electricity can be either AC, alternating current, or DC, direct current. The alternating current goes back and forth or oscillates rather than traveling in one direction. House current in the United States is AC and oscillates at 60 times in 1 second or 60 hertz. Voltage in the system is constantly alternating from positive to negative, which causes electricity to flow first in one direction and then in the other. Voltage alternates at a positive 110 to a negative 110 in the most economical way to transmit electricity to our homes and workplaces. Now, by decreasing current and increasing voltage, we can force alternating current to travel great distances. When alternating current reaches its destination, it's made more suitable for driving our electrical devices by decreasing voltage and increasing current. DC travels in only one direction and is the type of current that most electronic devices require, including computers. A rectifier is a device that converts the AC to DC, and an inverter is a device that converts the DC back to the AC. Now, a transformer is a device that changes the ratio of voltage to current. Large transformers reduce the high voltage on power lines coming into the neighborhood to lower voltage before the current enters your home. The transformer does not change the amount of power in the closed system. If it decreases voltage, it increases current. The overall power stays constant, but the ratio to voltage to current changes, and it's illustrated here behind me on the figure behind me. Now, there are ways of functioning as both a transformer and a rectifier. It steps down the voltage from the 110 volt house current to a 3.3, 5, or 12 volts and changes the incoming alternating current to direct current when the computer and peripherals, which the computer and its peripherals then require. The monitor, however, receives the full 110 volts of AC voltage, converting that current to DC. The direct current flows in only one direction. Think of electrical current like a current of water that flows from a state of high pressure to a state of low pressure or rest. Electrical current flows from a high pressure state called hot to a state of rest called the ground or neutral. Now, for a PC, a line may be either positive 5 or negative 5 in volts in one circuit, or 12 or negative 12 in another circuit. Positive or negative value is determined by how the circuit is oriented, either on one side of the power output or the other. Several circuits coming from the power supply accommodate different devices with different power requirements. Now we need to talk about the hot, neutral, and the ground. Now, when AC comes from the power source at the power station to your house, it travels on the hot line and completes the circuit from your house back to the power source on a neutral line, as shown here behind me. Now, when the two lines reach your house and enter an electrical device, such as a lamp, electricity flows through the device to complete the circuit between the hot line and the neutral line. The device contains resistors and other electrical components that control the flow of electricity between the hot and the neutral lines. Now, in a controlled environment, the hot source then seeks and finds a state of rest by returning to the power station on the neutral line. A short circuit, or a short, occurs when uncontrolled electricity flows from the hot line to the neutral, or when the hot line to the ground. Electricity naturally finds the easiest route to a state of rest. Normally that passes through some device that controls the current flow and then back to the neutral line. If an easier path, one with less resistance, is available, electricity will follow that path. This can cause a short, a sudden increase in flow that can also create a sudden increase in temperature, enough to start a fire and injure both people and equipment. Never put yourself in a position where you are in the path of least resistance between the hot line and the ground. A fuse is a component included in a circuit and designed to prevent too much current from flowing through the circuit. It is commonly a wire inside a protective case which is rated in amps. Too much current begins to flow, the wire gets hot and melts, breaking the circuit, as an open switch would, and stopping the current flow. Many devices have fuses which can easily be replaced and damaged. To prevent uncontrolled electricity from continuing to flow indefinitely, which can happen because of a short, the neutral line is grounded. Now, grounding a line means that the line is connected directly to the earth so that in the event of a short, the electricity flows to the earth, not back to the power station. Grounding serves as an escape route for out-of-control electricity. The earth is at no particular state of charge, and so it always is capable of accepting a flow of current. So the neutral line to your house is grounded many times along its way in. In fact, at each electrical pole, and it's also grounded at the breaker box where electricity enters your house. You can look at three-prong plug and see that the three lines, hot, neutral, and ground. Now generally electricians use the green or bare wire for the ground wire, white for the neutral, and black for the hot in-home wiring for 110 volt circuits. In a 220 volt circuit, black and red are hot, white is neutral, and the green or bare is ground. To verify what a wire is wired correctly, use a simple receptacle tester as shown here behind me. Now even though you might not have a 3-prong plug out in your home, the ground plug might not be properly grounded. Now to know for sure, always test the outlet with a receptacle tester. Now some common electrical components. It's important you understand that basic electronic components make up a PC and how they work. Basic electronic components in a PC include transistors, capacitors, diodes, and resistors, each of which we'll discuss later. The figure behind me shows the symbol to these components. Also notice in the figure the symbol for ground. To understand how these components are constructed, it helps that you know that all materials used to make the components fall into one of 3 categories. Conductors, materials like gold or copper that easily conduct electricity. An insulator, material like glass or ceramic that resists the flow of electricity. A semiconductor, material like silicon, whose ability to conduct electricity when a charge is applied falls between that of a conductor and an insulator. Now a transistor is an electronic device that can serve as a gate or a switch for an electrical signal, and it can amplify the flow of electricity. It was invented in 1947. The transistor is made of 3 layers of semiconductor material. A charge, either positive or negative, depending on the transistor's design, placed on the center layer can cause the 2 outer layers of the transistor to complete a circuit to create an on state. An opposite charge placed on the center layer can make the reverse happen, causing the transistor to be in an off state. Manipulating these charges to the transistor allows it to hold a logic state of either on or off. The on state represents the binary 1 and the off the binary 0, which holds a data in a computer. Now when a transistor maintains this state, it requires almost no electrical power because the initial charge sent to the transistor is not as great as the resulting current from that transistor. A transistor sometimes is used as a small amplifier. For instance, the transistors are used to amplify the tiny dots or pixels in an LCD monitor screen used to create a sharper image. It can also be used as the basic building block of an integrated circuit, or an IC, which is used to build a microchip. A capacitor is an electronic device that can hold an electrical charge for a period of time and can smooth the uneven flow of electricity through a circuit. They are used inside a PC power supply to create an even flow of current that the PC needs. Capacitors maintain their charge long after current is no longer present, even after it's been unplugged. You can see many capacitors on motherboards, video cards, and other circuits. A diode is a semiconductor device that allows electricity to flow in one direction. The transistor contains 2 diodes. 1 to 4 diodes used in various configurations can be used to convert AC to DC. Singularly or collectively, depending on the configuration, these diodes are called a rectifier. A resistor is an electronic device that limits the amount of current that can flow through it. In a circuit, a resistor is used to protect a circuit from overload or to control the current. Resistors are color-coded to indicate the degree of resistance measured in ohms. And that's all I have for you at this point. Be sure to go into your online management system, check to see if we have any labs associated with this topic, complete those, and then come on back for chapter 4, part 3.